Okay, very good morning to everyone. So now, with respect to our course, Artificial Intelligence, I hope you remember what we discussed in the last class with respect to knowledge-based system, right? So now, so before getting into the actual session for today, I'd like to have some discussion with you, followed by a game. Ready for that, all of you? Okay, I'll share my screen and you can see. Yeah, I think you can see my screen. So wherein it is just a sheet of paper. Maybe in MS Word application, I have opened that particular sheet. But the thing is about, I say that this particular sheet of paper is intelligent. So you may agree on this or you may disagree on this. So whoever agrees that this particular sheet of paper is intelligent, you can confirm that by raising your hands. Okay, good. So those who agree that this sheet of paper is really intelligent, yes, good. Those who don't agree, very good, because you cannot simply, agree on something without any proof, right? So now, for the proof part, so how this sheet of paper can be intelligent? I'll demonstrate that with a game. Now, this sheet of paper clearly shows you that it is 3x3 grid. So wherein there is a player A with some 4 coins and player B with some 4 coins with the distinct colors of red and blue. And I am going to act as player A by following the instructions given to me by that paper itself. And I want any one of you to play the role of player B. And the game is very simple. I think you all know that it's just the nuts and cross, or we used to call that as tic tac toe, right? Now, what I said, I'll be playing the role of player A, following the instructions of this paper itself, and you can use your own intelligence while you play as player B. Okay, let's start this game. Assume that it's going to be player A always takes the first move. Okay, so I'm going to follow the instructions given to me by this paper. So I'm making my move here, and it's the turn of player B now. I'm also going to make the move for player B since it is over online. So if it is offline, I think we can really play it well. And since it's only me here, so I'll be moving this coin for player B. So I can assume that player B moves here, and then player A, as per the instruction, I'm moving here, and player B will of course try to block this, and it will keep it here. And then you can see that player A will move here, and then player B will go any of the places here so that it may make a winning move the next time. But you can see here there is actually a gap wherein player A have placed 3 coins in a row horizontally at the third row. So the winner can be decided easily who places 3 coins in the same row or the same column or even diagonally. So you can see here at the first game wherein player A followed the instructions of the sheet and player B used his own natural talent, and we got to know that player A won the game. So this will not be the case always, right? So player B can be any person, and the moves may differ also. So in that case, I'm going to repeat it. I mean, let's play for another time. Okay, and as I said initially, it is going to be player A who always starts, which means the first move will be from player A. So this time, let us assume that player A goes here, and player B goes here, and again player A goes here, and player B goes here, and player A makes a move here, and player B may try to block it. Fine, and then player A will go here, and player B will place here. And at the end of this second game, you can see that it's a draw, which means none of the players have made it. So it is actually a draw. In the first game, player A is the winner, and in the second game, it is a draw. Let's try to play for the next time. So let me just clear all the moves, and this time, as usual, A is going to start by following the instructions of the sheet. Okay, that is the most important thing that I want everyone to remember. So player A, though I make all the moves, I'm not just doing it on my own. I'm just simply following the instructions given to me by the sheet. Okay, now so player A goes here, and player B goes here, let us assume, and A goes here. Of course, B will go here, and then A goes here, and B goes here if we say. And in this case, player A will actually made it first, followed by that player B also made one consecutive 3 coins. So in this case also you can see that it is actually 1-1. So 1 point for player A and 1 point for player B. So this also ends in a draw. So we have played some 3 different games. In the first one, if you see that it is player A who won, and in the second one it is a draw, and the third one it is actually a draw. The thing is, irrespective of number of times we play this, I can tell you for sure that it will be either player A who will win, or it will be a draw if it is a tough competition from the player B, or else it will be the player A who will win always. So why is it so? Who is that player A? The player A is just, I said, the sheet of paper itself, right? But following some instructions. What are those instructions? Let us see once what are those instructions and see what I am up to. Okay, and I'm going to show you the backside of this particular paper, wherein the instructions are given. You can see here, move one, go in a corner, which means, as I said, always player A in all the 3 games. If you have noticed, player A have chosen any one of the corner as its first move. Yes or no? How many of you have noticed? Right now, in the second move, if the other player did not go there, then go in the opposite corner to move one. And this also, I don't know how many of you have noticed. If not, I'll just show you a demo again. So herein, if you see, player A starts here, and wherever player B goes, what is the second instruction? If you see second move, if the other player did not go there, then go in the opposite corner to move one. What is the opposite corner to move one? This is my move one, right? So opposite corner will be this. So this will be my second move. If it is not moved by the, if this place is not taken by the player B, if it is already occupied, I have to go to some other corner. So that is what very clearly given in this instruction. And the move 3, which means I have to make the move, second move for the player 2 also. Now for the move 3, you can see here, if there are 2x, which means in nuts and cross we used to represent as x and o, right? So accordingly it has been written, if there are 2x's and a space is there, then go into that space, which means we have to make a move in such a way that you win by placing 3 consecutive coins. Else go in a free corner. Sorry, here. If there are 2x's and a space in line, then go in that space. Else if there are 2 O's and a space in line, then go in that space. Else go in a free corner. So let me use this instruction to make the third move. What is that? If there are 2x, which means 2 red, and a space in between, then I have to go in that space. If there are two blues and a space in between, I have to go in that space, else I have to go in a free corner. Okay, so for that, I'm going to first see if there are two reds with a space in between. No, there are no two reds with a space in between. And if there are two blues and a space in the line, see here, there are two blues here, and there is a space in this line, which means I have to block the opponent not to score. Okay, so for that, I'm taking the move here. It is actually the else if part that is getting executed. Yes or no? Are you able to follow, all of you? Else, if it is not the case, I have to go into any of the free corner. Right, this is my move 3. So let me make the move 3 for the player B also. Say for example, I'm making the move here. Now for the move 4, what is the instruction? You can see here. If there are two X and a space in line, go in that space. If there are two O's and a space in the line, then go in that space. Else go in a free corner or any space, any free space, because we cannot always expect a free corner. So whatever is left out, go there. This is actually the move 4. It is just one extension that we have added. Go in a free corner or in a free space if it is available. So let me try to do that. The first is what? If there are two reds and a space in the line, you can see here in row C, there are two reds and also a space. So I have to go here, and I made a score by placing 3 consecutive reds in a row. And player B will have no other option either to go here or there, but it doesn't matter. Wherever he goes, he is not going to score. Now, these are all just the 4 instructions that made this sheet of paper an intelligent one. Yes or no? That's how I started this, right? Whether this sheet of paper is intelligent or not, how many of you agree or disagree? So now tell me, how many of you agree that this sheet of paper is really intelligent in such a way that it always will win or will draw the game? It can never be beaten. And this is nothing but rule based systems. That's what we are going to see in today's session. What is it? Rule based systems. I'll just share another screen wherein you can see the things related to rule based system, and that is what our next topic is all about, because in last class we discussed about the knowledge based system, and now we are going to see about the rule based systems. What is it? It is going to include these and all other, these are these things and all, starting with the rules and facts, and that's what we are going to see now. What is it? A rule based system is of course a part of the knowledge based system, wherein the knowledge base is represented in the form of some set of rules. So what are rules actually? Rules are actually the way of expressing the knowledge in the form of, or it will be always straightforward, it will be always flexible, it will be expressive. Let me give you an example. One simple production rule will be always in the form of, if condition, if it is condition is true, then conclusion. You can see here, if condition, then conclusion. One example also I have given here. What is that? If the tap is open, then water flows. If condition, then conclusion. One simple example of a rule. And a simple rule like this, if you see, it is very intelligible, which means anyone understand English will be able to understand this. But of course, rules written for a complicated system will also be complicated, will be of complexity level high. But that rule will also be easy to understand than any programming codes. Okay, but for these rules to be applied, we need to have something called fact. What is that fact then? Facts are nothing but the unconditional statements which are assumed to be true at the given point of time. Whenever we are going to use that, it is assumed that it is actually true. So the general format of fact will be if true, then then the conclusion. What is that? There is no condition because the condition is assumed to be always true. That is what the general fact, that is how a general fact will look like. If true, then the tap is open because we have eliminated the condition here because the condition is going to be always true if it is a fact. And these facts can be looked up from a database. It might have already been stored in our memory. So we may use some sensors to fetch the details, or we can also ask the users to give the information, or we can derive some facts by applying rules. These are the various ways in which we can get facts. And remember, facts are nothing but special rules when the condition is always true. Because the general condition of rule is what? If condition, then conclusion. If the condition is not there, which means if it is always true, then the conclusion. That is what known as fact. So now, as I said, with this example itself, what if the tap is open? This is actually the rule for us, right? And the fact is what? Water flows, right? So here, this particular rule and fact will help us to derive another fact. What is that? This rule, if the tap is open, then water flows. And the fact tap is open if it is always true. If the fact is, if it is a fact, then it means it is always true. So this rule and the fact will together help us to derive additional facts known as derived fact. So when you have more number of facts, what is the thing that we have to do? We have to store it somewhere, and that particular thing, collection of fact, is what called fact base. What is it? These are all actually the components of the rule based system. We started with the rules and then fact. Now we got to know what is fact base. Now, who will do all these things? Who will declare the rules? Who will use the fact? Who will interpret all these things and derive additional facts? It is nothing but the inference engine, one of the major component of a rule-based system. This inference engine is the one who will interpret all the rules. It will apply the facts and derive some additional facts or rules, which is the inference engine. This inference engine, it will be a kind of software. We can incorporate that into some software. It will have some toolkit software libraries are available actually to create some inference engine. And if we want to create an inference engine, and it has to start with writing rule for the particular system. And these rules, as I said, will not be generic, will be specific for applications. And something like that is what I have shown you initially. What is it? The rules for the tic-tac-toe game. That is how you always used to play against a computer. The computer follows what? These simple rules, and not anything other than that. Based on the rules only, the computer always used to take moves. So whatever the instruction that I have shown you in the document are all the rules for the tic-tac-toe game for the computer. Whoever may be the opponent, the computer will just follow the rules and take some actions. And this is what the introduction to rule-based system. And in the next class, we will see an example how exactly a rule-based system for a boiler controller system can be created. Next, we will see how the rules has to be examined and how the rules has to be fired. So followed by that, there will be some conflicts, and for that, we will use three different approaches. The one is the forward chaining, backward chaining, and hybrid search strategies. So these are all the next set of things that we will be seeing in the next consecutive sessions. So that's all for today.